When we get into chapter 4.2, we learn what's called the general power rule. Who likes to find the derivative by first principles using that difference quotient? Nobody. So here's our general power rule. If y equals ax to the n, and you see this many different ways, but I'm conveying it correctly here, anx to the n minus 1. So what is this? It's a time saver. What are we doing here? Well, we are finding the derivative instead of by first principle using the difference quotient, simply by multiplying and subtracting. Multiplying what? Well, what we're going to multiply is our exponent times our coefficient, and then we're going to subtract 1 from the exponent. So you'll hear me say multiply and subtract, multiply and subtract, multiply and subtract. And so if we have, let's do a few examples, see how this works. If we have y equals 8, well, we can assume any constant has an exponent of 0 attached to the x. The exponent of the actual number there, the coefficient is 1. So when we find the derivative here, y prime equals 8 times 0, x to the 0 minus 1, which is equal to 0. If y equals 219, or y equals 462, or y equals negative 57, I know y prime in each case is going to equal 0. So there's our first lesson. The derivatives of constants are 0. If we take something like y equals 8x, well, that's 8 x to the first. We call this linear. When we take the derivative here, y prime equals 8 times 1, x to the 1 minus 1. So y prime equals 8 x to the 0. So y prime equals 8. Notice we've now got another shortcut. Whenever we're given a linear term, the derivative will simply be the coefficient. So I could say y equals 19x, y equals 58,000x, y equals 72x. So y prime is 19, y prime is 5,800, y prime equals 72. You can get very quick at this by recognizing x to the first means the derivative goes to the coefficient. Now, combined with y equals ax to the n, y prime is a n x to the n minus 1. There's our general power rule. We've got another rule that will allow us to evaluate the derivative of polynomials. If y equals f of x plus or minus some other function g of x, and I could keep on going and going, plus h of x plus j of x, etc., etc., etc. You get the idea here. Then y prime is the derivative of this term plus or minus the derivative of this term. So this is our sum and difference rule of derivatives. So we're going to use both of these rules in conjunction in order to find the derivatives of polynomials, which we studied their graphs of in our last section. So I'm going to love these two rules because they're going to save me from having to find the derivative using that difference quotient. Using these two together, we can say something like f of x equals 8x cubed plus 19x squared minus 4x plus 13. And we can find the derivative by multiplying, subtracting. 8 times 3x to the 3 minus 1 plus 19 times 2x to the 2 minus 1 minus 4 times 1, because there's a 1 there, x to the 1 minus 1. And of course, nobody writes this, but we have to understand it's there. So this finally will become plus 13 times 0, x to the 0 minus 1. So our derivative here will be 24x squared plus 38x minus 4. Do I ever really write this second step? No, of course I don't. for instructional purposes only, I want to show you how I got this derivative. But of course, I jump from that first step to the third step because the math is easy. All I'm doing is multiplying and subtracting, multiplying, subtracting, multiplying and subtracting. So that was a very straightforward polynomial. What if you have something like f of x equals x plus 2 times x minus 3? We don't yet have a rule for finding the derivative of something times something. All we have is a rule for the derivative as a polynomial. So what we want to do is put it in derivative-friendly form, so then we can apply a combination of these two rules. So we have some algebra to do, and of course our algebra here is FOIL. First times first, outer negative 3x, inner plus 2x, last minus 6. Can I clean that up? Heck yeah. X squared minus x minus 6. Now it's in the form that allows us to take the derivative. Multiply and subtract, and you should at this point go, oh, I see how he's doing that. Constants go to 0. Linear terms go to their coefficients. And for the x squared, I simply multiplied and subtracting. So in that case, I'm showing you sometimes you need to FOIL first because we don't have a rule. We don't have a rule to deal with this. Something times something, I didn't give you a rule for that. So write it in derivative-friendly form first. If I give you something like f of x equals 3x squared times 5x squared plus 4x minus 2. Again, I don't have any derivative rule that allows me to find the derivative of some term times, this is a trinomial in this case, yet I don't have a rule for that. So I have to write it in the form of a polynomial. How do I do this? Well, what I'm going to do this case, not FOIL, but I'm going to distribute the 3x squared. So I'm writing my function again. 3 times 5 is 15. Some rules. A to the m times a to the n is a to the m plus n. So that allows me to write this as x to the 4th because I'm adding 2 plus 2. 3 times 4 is 12. This is to the 1st. So this becomes x to the 3rd. How? 2 plus 1 in this case. And then 3 times negative 2 is 6x squared because this is x to the 0. 2 plus 0 is 0. Only now, in this form, am I in derivative-friendly form. So I'll do f prime of x is equal to multiply 60 and subtract. Multiply 36x and subtract. Multiply 12x. So there is my derivative. Now, don't forget that this function gives us the slope of the tangent. It's easy to get lost just finding derivative after derivative and forgetting what it means. If I give you something like this, our function is equal to 4x cubed plus 2x squared minus 8x plus 10, all divided by 2x. Well, I have to understand if I have a single monomial, this is a single term in the denominator, I can divide it into each and every term up here. So I could write this as f of x equals 4x cubed divided by 2x plus 2x squared divided by 2x minus 8x divided by 2x plus 10 divided by 2x. And then I have to remember if I have a to the n divided by a to the m, this is a to the numerator minus denominator exponent. So I haven't yet taken the derivative. 4 divided by 2 is 2. X to the 3 minus 1 is x squared. Plus 2 cancels with 2. X to the 2 minus 1 is simply x to the 1st. Minus 8 divided by 4 is 2. X divided by x cancels to 1. By the way, some students tell me these cancel to 0, but x over x is 1. Depends on what we put in for x. So, but don't cancel those to 0. And finally, 2 goes into 10 5 times. 5 over x. We're still not done. If I have 1 over a to the n, I can write this as a to the negative n. What a great review of exponents this is. So I can write this now as f of x equals 2x cubed plus x minus 4 plus 5. The 5 has an exponent of 1. The only thing we're bringing up is the x. So now, and only now, can I find the slope of the tangent. Multiply and subtract. Plus 1. Yes, the derivative of x is 1. 4 goes to 0. And finally, I have 5 times negative 1 is negative 5x to the negative 2. If you have trouble with that, think about the number line. Negative 1 minus 1 gives us negative 2. If I stipulate you must write your final answer with positive exponents, then the slope of the tangent, the derivative f prime of x, is 6x squared plus 1 minus 5. The 5 is happy where it is. Leave it there. It's only the x that is going down. So this would be not just a fine answer, but a wonderful answer to this particular problem when they ask us to find a derivative. Sometimes we have to FOIL. Sometimes we have to multiply out, distribute. Sometimes we have to divide if we have a single monomial. Why do I mention single monomial? Because you can't do this. If you have f of x equals 4 over x plus 3, this does not equal 4 over x plus 4 over 3. And you can prove that to yourself with numbers. You can't do that. No, 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 no.